Okay. So Shahina, we did a lot of examples, almost all the examples and review questions too. So when you're doing your homework, you just have a look. If possible, if you have time, I suggest you to solve them one more time without looking at the solution, okay? You'll see. But actually, at least almost all of the questions we solved here together. Now you got some idea about how should we approach the questions, how should we think, and how should we form the equation, blah, blah, okay? So two more questions left here, 19 and 20. They're a little bit different questions. It's a kind of similar to systems of linear equations, and more about this actually in detail, we will learn later. So here it's a very simple question, given that A, B, C, D are whole numbers. Okay, what we mean by whole numbers, let me just write here W, whole numbers. Okay, you know what are whole numbers, right? Starting with 0, 0, 1, 2, 3, 4. These numbers are called whole numbers. What is the difference between whole numbers and the natural numbers? Actually, 0, we do not consider 0 as a natural number. The only difference is if you just add 0 to natural number, it becomes whole numbers, okay? If I just delete the 0, 1, 2, 3, they're whole numbers. Actually, they're also natural numbers, okay? But here, A, B, C, D are whole numbers. We mean they are these numbers. They are not like fractions, or they are not decimal numbers. And such that A plus B equals 8. Let me just write them here. What is given? A plus B is equal to 8. And B plus C, the second equation, B plus C is equal to 11. And third equation, B plus D is equal to 13. And the last equation, C plus D is equal to 14. So what we have here, we have 4 equations. And we call this a system of equations in math. But this is a very, very simple example. Okay. So how do you solve? Usually we solve systems of linear equation in 2 different methods, but more common method is elimination method, okay? Elimination method means we try to eliminate some variables here. That means that we'll get less equations. Maybe out of these 4 equations, I will get 3 equations. Out of 3 equations, I'll get 2 equations. Out of 2 equations, we get 1 equation. Then actually moving backward, we can get all the values of these variables. Now, if you just look at these 2 equations, for example, here. Okay, if we just subtract side by side, what happens? B plus D minus C plus D. Here we have something like this. If you just subtract side by side, D minus D, they cancel each other. B minus C, it is B minus C equals 13 minus 14, so that's equal to -1. And do we have any equation here in B and C? Yes, here I have another equation, right? Let me just write here. B plus C, I have another equation. How does B and C are connected to each other? 11. Now, as you see here, if I just add this together, we can eliminate C. So if you just add them side by side, again, one more time, B plus B equals 2B. Negative C plus C, that's equal to 0. -1 plus 11, that's equal to 10. Now, 2 times B equals 10. What is B? B equals 10 over 2. That's equal to 5. So 2 times B, 2 times 5 is equal to 10. So that is the value of B in this equation. So now we just work backward here. From here in this direction, we can get all the values of other variables. For example, if I substitute this here, for example, I know the value of B now, right? What is it? 5. So 5 plus C is equal to 11. What is C?
C.
5 plus what number equals 11?
Oh, sorry, you froze. I couldn't hear that.
Okay, here we have 5 plus C equals 11, right? Can you hear me now?
Oh, yeah, I can hear.
Okay, so what is the value of C then here?
That is 6. Yeah, 6.
6.
C.
Now we got a second answer. Now I will substitute this in where we have C here. For example, if I substitute here, okay, we got this. So if I substitute here, we can get the value of D, right? use this equation. C plus D is equal to 14. So what is C? I know the value of C. Substitute here. 6 plus D is equal to 14. Then what is D? Subtract 6 from both sides. So here we have 14 minus 6. That's equal to 8. And now I can substitute this 8 here, for example, or B. What is B? 5. Substitute here. From here, A plus, what is B? B equals 5. So that's equal to 8. So from here, what is A? A equals 8 minus 5. That's equal to 3. Now we got all the answers. Dots, dots, dots. And here we have A in alphabetical order is equal to 3. And B, what is B? B is here. That's equal to 5. And C, what is C? It is equal to 6. And how about D? D is equal to 8. Now, if you check this, actually, all these numbers satisfy this equation. A plus B, 3 plus 5, 8, that's correct. B plus C, what is B? 5, C, 6. 5 plus 6 equals 11, correct. And B, 5, D, 8. 5 plus 8 equals 13, that's correct. C plus D, what is C? C equals 6, D equals 8, 14. Right? So that is the solution of the given equations, given system actually here. Now we will see another similar example, but instead of added here, we'll have multiplication. Can you read it?
Given that A, B, C, and D are whole numbers, such that AX, A times B equals A, B times C equals 28, C times D equals 63, and B times D equals 36. Find the value of A, B, C, and D.
Very good. So now, again, well, we know what we mean by whole numbers. They are like 0, 1, 2, 3, 4. And what is given here? A times B. That's equal to 8. The first equation. How about the second one? B times C. B times C is equal to 28. And from here, the third one, C times D equals 63. And the last one, B times D, that's equal to 36, right? So here all the things are multiplied by each other. How can we actually eliminate the variables? By division, right? For example, here, let's say here, for example, here we have AB and BC, right? What happens if we just divide them side by side? Here we have A times B over B times C. And what is A times B? A times B is 8. And how about B times C? B times C is 28, right? So here we have, these are common factors. A over C is left. And also, can you simplify this fraction, Shahina? It is divisible by 4, right? Also, 28 is divisible by 4. 8 is divided by 4. It is 2. And here we have, it is 7. Right? So now, okay, we got A over C equals 2 over 7. Now, do we have anything here that has, okay, C. All right. Okay. And how about this two? Okay, let's wait. Here now we'll get this answer. How about if we just divide this, the third equation, by the fourth equation? Here we have C times D over, here we have B times D. What do we have here, Shahina? Tell me, what should I write here?
63.
63. How about here?
36.
36. So immediately we should simplify this. This D, they cancel out each other. And also on the right-hand side, we can simplify this fraction. And both are divisible by 9, right? This thing is 7 times 9. And this thing is 4 times 9. So this thing cancels each other. So here we have C over B is equal to 7 over 4. Now, Shahana, you should be careful. I can't say that C equals 7, B equals 4. I cannot say that. But what we know that here, the ratio, if I divide C by B, it is 7 over 4. Okay, it may be like If you multiply by 2, it may be 63 over 36. It may be 14 over 8. A lot of options, but we don't know yet. But I have another information here. C times D equals 63. So now if I write here C times, no, not this one. Let's use the second equation that has B and C. So the second equation has B and C, right? And also we know that B times C is equal to 28. Now from these two equations, if you multiply side by side, for example, C over B, and multiplies by B times C, B times C. C over B, that's equal to 7 over 4, and B times C equals 28, right? So now we can cancel this two things. What is C times C?
2C.
Hmm?
2C, right?
C times C. C times C. What is 3 times 3?
6.
Are you sure?
Oh, wait, no. 9.
It is 9. What is 4 times 4?
16.
So what is A times A?
2A.
What?
Wait, what?
A squared.
Oh, true.
Is we are multiplying, not adding here. Right? 4 times 4, that is 4 squared, that's 16. 3 times 3, 3 squared, that is 9. And 4 times 4, 4 squared, that is 16. So here we have C times C, that is C squared. On the right hand side, can you simplify this? Tell me the answer. Can you simplify this?
5, 7, 4. That's 28 times. Isn't it 28 square?
No.
No.
Here we have 7 over 4 times this 28. We can write it as 4 times 7, right?
Uh-huh.
So this 4 cancel out each other. What is 7 times 7? 7 squared.
9. Oh, yes.
So now we have C squared equals 7 squared. And we know that C is a whole number. It's not a negative number. What is C then here?
Let me see it.
7. Because 7 squared equals 7 squared, right?
Uh-huh.
So C must be 7. Okay?
Okay.
So now we got 7. All right, now we can answer. Just moving backward or working backward. So C is 7. Shahina, tell me now, if C equals 7, what is B here? What number times 7 equals 28?
4.
That is B equals 28. So what is B? B equals 28 over 7, which is equal to?
4.
4. So now we got the value of B. I know the value of C. Continue. If I know B, now I can find the value of A, right? From the first equation. A times B. What is B? B equals 4. On the right-hand side, we have 8. What is A?
2.
2. Also, we got the value of A. Now we need to find D. So either using this equation or this equation, we can get the value of D. From here, if you use this equation, here we have, what is B? B equals 4. 4 times. How about D? We don't know yet. 36. So what is D?
Equals 9.
9. So the answer here we have, you can just write the answer here. So let me just put all the answers in this box. A equals 2. B equals, what is it? It is here. That is 4. And C equals 7. D equals 9.
Oh, I see.
Okay, now if you just substitute all of these numbers into the equation, it will actually make true statement. It will be the solution.
Wow.
Okay?
Okay.
So Shahina, for now, that much is enough about algebraic equations, linear equations. You just keep practicing. Actually, we'll get back to these equations again. Now, a bit more complicated equations. Now, chapter 3 is about number sequence. It's also a very easy chapter. So now we'll talk about number sequence, okay? So now I'm finishing this chapter 2. So as soon as possible, you have to finish chapter 1 and chapter 2, and you have to send your assignment to me, okay?
Wait, should I send it to you after I'm done with both chapters, or?
Yeah, after you finish chapter 1, scan it, right? Take the picture, save it as a PDF file, and send it to me if you have already finished. And after you finish chapter 2, also you have to send it to me through your WhatsApp.
Okay. I think I'll be able to send it today.
Okay, good.
I just have like 2 questions left.
Very good.
2 or 1. Yes.
Okay. Now we will talk about number sequences. Okay, this chapter 3 is about number sequences. Very easy chapter. At least we'll get you be familiar with some terminologies. Okay, and what we mean by number sequence, and the solve problems involving number sequence. What we are going to learn in this chapter, we have 2 objectives here. Number 1 is we will learn how to recognize simple patterns from various number sequences. If you are given a number sequence, immediately have a look. Can you see the rule? Can you see the pattern? How actually we are producing new terms, okay? That is what we are going to learn. Number 2 is how to continue a given number sequence and find their general term. Actually, these 3 things are the most important things that we're going to learn in this chapter. So I'll just first start with very simple number sequences, and after that I'll get back to this problem in the introduction. Actually, we have a problem about rabbits, okay? I'll get back to this problem a bit later. First, to get used to these number sequences, let's see a few examples. First, what is a number sequence? Simply, number sequence is a list of numbers, a collection of numbers that are linked by a rule. Okay, so if you work out the rule, you can work out the next numbers in the sequence. It means that if you're given a number sequence, if you can see the rule or if you can see the pattern, how actually they are producing other terms, then after that we can just write any term of the sequence without writing this. Okay, for example, let me just start with very easy number sequences. When you say number sequences, the first thing that comes to our mind is, what is it? Natural numbers, counting numbers. For example, if I just write here 1 and 2 and 3 and 4. Now, if I ask you, Shahina, what is the next number?
5.
5. And after that, what is the next number?
6.
6. Next number, 7. Immediately you can see the pattern, right? Here, what is the rule here? So here, to write this number sequence, I started with 1, right? I started with 1. And after that, to get the next term, we are just adding 1, right? So again, also here, we are adding 1, adding 1. So immediately, as you see here, after writing a few terms, you can see this pattern. How you answered my question, because you already noticed the pattern here, okay? And every time it may not be easy to see this pattern. These are very simple number sequences. So next example is, how about this one? 2, 4, 6, 8. What is the next number?
12.
What?
No, 10. 10.
10. It is 10. And next term is 12, right? Next term is 14, ... continues. So now immediately, as you see here, you can see the pattern, right? Oh, here we start with 2, and to get the next term, we should add 2, right? We should just add 2. All right. And how about this number? For example, let's say 3, 8, 11, 14, 17. What is the next number?
Wait, hold on.
Oh, Shahina, sorry, I made a mistake. Wait, let me correct this. Let's say here we have 5.
Yeah, I was confused at the beginning.
Yeah,
So
sorry.
the next will be 20. Right? Yeah,
Next
20.
term, actually each number in the number sequence, we call it a term. Okay, term.
So the next term
Next
is
term
20.
is 20, and next term is 23. So what is the rule here? Can you state the rule?
Plus 3.
Start with 5, right? But also you need to tell, no, we should actually state the starting point. Start with 5 and add 3 to get the next term. That's the rule, right? Start with 5 and add 3 to get the next term. Very good. Let me just see if you can answer this question. How about this number sequence? 1, 1, 2, 3, 5, 8. What is the next term here?
Plus 1, 2. Wait, hold on. Plus 1, 1, 2. So that's 1.
Can you see the pattern here? What kind of pattern is there?
I have the idea. It's like I remember how to do it. I just kind of forgot a bit. But well, I know that the beginning, it's like starting it again, like 1 plus 1 is 1, 2, 3. Oh my god, I forgot how to do it.
Okay, now if you look at this, if you just add, okay, start with 1, and the second also term is 1, and after that to get the next term, add the previous two terms. 1 plus 1, it is 2. Now if I add the previous two terms, 1 plus 2, it is 3. And 2 plus 3, it is 5. 3 plus 5, it is 8. What is the rule here? Start with 1 and also the two ones, and to get the next term, add the previous two terms, right? That's the rule. So then the previous two terms, 5, 8, so this will be 13. And now if we add this together, this will be 21. Add together, this will be 34, right? And continue. Actually, that's a special number sequence. We'll talk about it a bit later. It's about that rabbit thing, okay? So the last example, let me just see the last example. How about this thing? 1, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 1, right? What is the next number?
1, 0, 0, 0, 0, 1.
4 zeros,
Yeah, 4.
right? 1. Now you can see the pattern. Very good. So now let's say a few examples. Now you'll answer. And first, see this, okay? And the state a rule first. And after that, write the next three terms. Okay, I have two questions. Look at the number sequence in question A. So what is the rule? What pattern do you see here?
Let's see. Oh, I think you
Start with 3, right? Because the starting number is 3. Start with 3 and
add 5 and then add 10.
okay, add 5 to get the next term. That's all. So the rule is start with 3 and add 5 to get the next term. So 3 plus 5, 8. 8 plus 5, 13, right? Plus 5 and plus 5. 13 plus 18, it is, 13 plus 5, 18. So the next term will be 18 plus 5.
Oh, 23. It'll be
So
23.
18 plus 5, it is 23. 23 plus 5?
28.
28. 28 plus 5?
33.
Very good. It says only 3 terms. That much is enough. Actually, it continues. So just writing 3 terms is enough. Question B. Can you state the rule? Start with 38 first, right? Start with 38, right? And what do you see here? Subtract. Hello.
Sorry,
Okay.
the computer froze. Like, I never really.
Okay, no problem. So,
I said,
Shahina, we'll talk about question B.
yeah, I said subtract 6.
Very good. The rule here is start with 38, right? And subtract 5 from the previous term to get the next term. So 38 minus 6, or 6, not 5. 32 minus 6, right? That is also minus 6, and there's also minus 6. So can you just write down the next three terms? 20 minus 6.
14.
14. 14 minus 6.
8.
8.
Yeah.
8 minus 6.
2.
2. Very good. Just three terms, that's enough. How about the next example? What is the pattern here?
Multiply by 3.
Good. Start with 2, right? Start with 2. And multiply by 3 to get the next term. So 2 times 3. 6 times 3. 18. 18 times 3. 54. What is 54 times 3? You can multiply like this. 54 is 50 plus 4, right? 3 times 50, 150. 3 times 4, 12. So what is it? Is equal to 162.
Oh,
right?
That's easier.
So that's 162. Now, what is 162?
2 times 3, that's, let's see.
3 times 2 is 6. Okay. 3 times 6, 18. We have 1. 3 times 1, 3. With 1, it is 486. Right? And now we should multiply this by 3. 3 times 6, 18. We have 1. 3 times 8, 24. And with 1, 25. We have 2. 3 times 4, 12. With 2, it is 14. Right? So it is 1,458. Okay, Shahina, how about the last example? Can you say the rule for this number sequence?
Wait. Oh, I get it.
Very good. What is this?
I'm not quite sure, but like if you do it the opposite, 16 plus 16 is 32. 32 plus 32 is 64. 64 plus 64 is 128. But
okay, now how can I get 64 from 128? So start with 128 and divide by 2 to get the next term. Right? So here we have divide by 2. 128 is divided by 2, 64. 64 is divided by 2, 32. 32 is divided by 2, 16. And 16 is divided by 2?
8.
8. 8 is divided by 2?
4.
4. 4 is divided by 2?
2.
2. And 2 is divided by 2?
1.
And 1 is divided by 2.
Wait.
1 over 2.
Oh.
Or if you can continue, right? Then here we have 1 over 4, 1 over 8, 1 over 16, dot, dot.
Also,
Actually, yeah, we are asked only to write this thing, right? That is enough. Okay? So in similar way, you will do the exercises that I have already sent. Oh, I don't know. I'll check this. Otherwise, I will send you after class. So now let's talk about Fibonacci sequences. Okay. So actually this Fibonacci sequences, this guy was inspired by this problem. Can you read this?
Suppose a pair of newborn rabbits take 1 month to mature and start to reduce a pair of offspring 2 months after they are born. They reproduce a pair of each month after that. If we start with a pair of newborn rabbits on January 1st, 2010, how many pairs of rabbits will there be on January 1st, 2020? This problem will lead to an interesting and useful number sequence.
Okay. What is it saying? That suppose a pair of newborn rabbits. You just go to the animal bazaar or animal market and you buy a pair of newborn rabbits, the tiny one, little one. And you bring home, it says that it takes 1 month to mature. That means that in 1 month they become adult, right? And they start to reproduce a pair of offspring. So here you go to the market, that is the first month. Now they are babies, right? And after still we have 1 pair. After 1 month, okay, still you have a pair of rabbits. Now they are mature. So after 1 month, third month, they give babies. Now they have new babies. These are their babies. And they are itself. These are our adult rabbits. Now, once they actually become mature, every month they reproduce and give new 2 babies. So here, these are our adult babies, right? From here, babies, they become mature. Now here they give babies. So themselves, right? Here we have new babies. Now here they are first new babies. It takes 1 month for them to mature, right? After 1 more month, now again also they give, what is it? New babies. Now if you just write the pair of rabbits here, the first one, the first month, we have 1 pair of rabbits, right? And the second month, still we have, because they are just mature now, so still we have 1 pair of rabbits. And the third month, now our rabbits mature enough, right? Now they reproduce, now they have 2 babies. So now how many pairs of rabbits we have? Here we have 2. And how about 4th month? Now actually they reproduce new one, so now they are becoming mature. How many pairs of rabbits we have? Here we have 1, 2, 3 pairs. So here we have 3 pairs. How about 1st, 2nd, 3rd, 4th, 5th month? How many now we have? Now actually they are already mature, so they reproduce new babies, right? And these guys, again, they continue reproducing. And now, actually here, now they become mature here. Okay, if you count this here, we have 1, 2, 3, 4, 5 pairs. Now here 5 pairs. If we just write 1 more row and 1 more row, we can continue. But here, we have enough information to see the pattern. As you see here, we got that number. Actually, that number is called Fibonacci numbers. Here we have 1 plus 1, it is 2. 1 plus 2, it is 3. 2 plus 3, it is 5. 3 plus 5, here we have 8. Now that means that at the end of 6 months, we will have 8 pairs of rabbits. At the end of 7th month, we will have 13 pairs of rabbits. And it continues, 21. And after that, what is it? 34.
That's okay. A lot of rabbits.
So this is actually very important number sequence. You're going to see this a lot. Maybe at secondary school, at university, even at university, if you study some courses, actually you will see this because it has a lot of application. Okay. One application is now if you just take the ratio of 2 consecutive numbers here. When you have free time, you can try this. You can write more. For example, here, 34, 21, 21 plus 34. Here we have 55. 34 plus 55, that is 88. and 88 plus 55, that is 144, and 144 plus 88, 89, right? Here we have 89. 89, it is 220, 233 continues. Now, if you just take the ratio of two consecutive numbers, 1 over 1, evaluate this, what is it? 2 over 1. Evaluate this, calculate this. Now it's 3 over 2. And the 5 over 3, for example. And the 8 over 5. And the 13 over 8. And here we have 21 over 13. When you have free time, just continue. Maybe you can just write 10 of them. Now here we know that that's equal to 1. This is equal to 2 over 1, that is 2. And this one is 1.5. This one is 1.6 something. And this one is 1 point something. All right. As you go further and further, you'll see that this ratio will get very close to very special numbers, approximately equal to 1.61 something, blah, blah. Okay. In math, actually, that ratio is called, it has a special name. We call this golden ratio. Golden ratio. Maybe in your free time, you can just do some research, Google, okay, what is golden ratio? Or golden ratio in nature, golden ratio in architecture, golden ratio in human body, golden ratio in physics, okay? It has a lot of application, okay? Anyway, that is Fibonacci numbers. And one more thing, just to give you some idea, I'm going to write this. We have another beautiful numbers, sequence, that actually collection of numbers, they have very beautiful pattern. That is called Pascal's triangle. What is it? This Pascal's triangle, we start with 1, like Fibonacci sequence. And after that, again, I just write here 1, and here we have 1. Now, to write, this is the first row, that's the second row, and how about the third row? And also I write here, I write 1, and add these two numbers, here we just write 2, and here we have 1. And fourth row, just write here 1, 1 plus 2, it is 3, 2 plus 1, it is 3, and here we have 1. And how about the next row? Here we have again 1, 1 plus 3, it is 4, 3 plus 3, it is 6, 3 plus 1, it is 4, and here we have 1. Continue. Here we have, sorry?
That is really cool.
Yeah, that's cool, beautiful, and also it has very beautiful applications. And here we have 5, 1. Okay? So now, for example, maybe in the future we will see this in our next course. For example, if we just expand this, a plus b to the power 5, for example. That means that a plus b times a plus b, that's the 0, first, second, third, fourth, fifth. If you just expand this, actually we have ABs, but coefficients of this ABs. Okay, we will have this thing. Here we will have A1, and here we will have 5, here we will have 10, here we will have 10, here we will have 5, here we will have 1. The coefficients of these ABs, I'm not writing them here. Actually, it will be these numbers, 1, 5, 10, 10, 5, 1. Okay? But actually, you see what is the pattern right here? 1, 1, 1, 1, 2, 1 plus is 3, and here we have 1. Now here we have 4, 6, 4. So I wrote here 1 plus 4, 5, 10, 10, 5. You can just continue this. It has other applications, but just I want to give you some information. That much is enough for you now. And the details maybe we'll learn in the future. Shaheen, it is 9:43. Okay. You may be a bit tired. Have some rest. After 10 minutes, we will continue. Okay?
Okay.
Have some rest. Okay.